Good morning, students. Our today's topic in the topic of acid, bases, and salts in the subject of chemistry O levels is reversible reaction. So this is very important topic. Again, a technical topic. A lot of concepts will be involved. So concentrate yourself. So first thing to remember is this is the sign that will be used for reversible reactions. So concentrate yourself. We are going to start now. Changes which can go backward and forward are called reversible reactions. So this is the definition, this is the concept of the reversible reaction. Changes which can go backwards and forwards are called reversible reactions. A reversible reaction is a reaction that can take place in both direction, means in forward as well as in backward direction. A reversible reaction is made up of forward reaction and a backward reaction. When the rate of the forward reaction is equal to the rate of the backward reaction, the reaction is said to have reached a state of dynamic equilibrium. Very important concept. So this is the point to remember. When forward reaction becomes equal to the rate of the backward reaction, that state will be called dynamic equilibrium. When a chemical reaction reaches a state of the dynamic equilibrium, the rate of the forward reaction equals to the rate of the backward reaction. The concentrations of the reactants and products remain unchanged because the reaction has reached a state of the dynamic equilibrium. The rate of the forward becomes equal to the rate of the backward reaction. So the concentration of the reactants and products will remain unchanged at that state. The composition of an equilibrium mixture in a reversible reaction can be altered by changes in. So there are three changes that can be made to take the reaction out of the dynamic equilibrium, or their rate can be, rate of the forward or backward reaction can be changed by changing three conditions. And the conditions are: number one, concentration; number two, temperature; and number three, pressure. So Le Chatelier's principle is used to predict the change in the composition. Le Chatelier's principle states that if the conditions of a system in dynamic equilibrium are altered, the system will move so as to oppose the change. Okay, first thing that we are going to read is the changing concentration. So here is a reaction that is reversible reaction, and the dynamic equilibrium state has been reached. So look now, if more A, and A is a reactant, if more reactant will be added into the reaction, so don't you think the number of the particles, the amount of the reactant will be increased? There will be more collision of the particles of the reactants, and then reaction will move towards right. So more product will be going to be produced. So this will be the thing which will happen now. So look now, equilibrium moves to right to reduce the concentration of the A. Here are three. Here is a table that will explain you more. So look now, if the concentration of the reactants are increased, so definitely there will be more number of the particles of the reactants. They will collide more frequently now, and definitely the shift in the position of the equilibrium will be towards right, and the reaction yield will be increased. And on the other hand, if the concentration of the reactants are decreased, definitely there will be less number of the particles of the reactants will be there. So they will, the effective collisions will be less. So definitely shifting the position of the equilibrium will move towards left, and reaction yield will become decrease. Okay, on the other hand, if we increase the concentration of the products increases, so it means the concentration of the reactants will be decreased. So ultimately, if reactant particles are less and they are less colliding with each other, less effective collisions are there. So shift in the equilibrium will towards left, and reaction yield will become will decrease. And if the concentration of the product is decreased, so look now, if the concentration of the product is decreased, in other words, it means that the concentration of the reactants will be increased. So there will be more number of the particles of the reactants. They will collide more. Effective collision will be more. So the shift in the position of the equilibrium will be towards right, and reaction yield will become increase. Next thing that we are going to read is the changing temperature. So look now, increasing temperature can change the direction of the equilibrium reaction. So look now, if the exothermic reaction is there, so exothermic reaction is a reaction in which heat is given out. So keep this in your mind, heat is already given out in exothermic reaction. So if you increase the temperature, that will have bad impact on the temperature. So it means shifting the position of the equilibrium will be towards left, and reaction yield will be decreased, because increasing temperature is having bad impact, because the reaction is already given out heat. So if you increase the heat, so it will have bad impact. And on the other hand, if you decrease the temperature, yes, this will have good impact on the reaction, because the reaction is already given out heat. And if you decrease the temperature of the environment, that will have very positive impact on the reaction. So the shift in the position of the equilibrium will be towards right, and reaction yield will be increased. Okay, now we are going to discuss endothermic reaction. So endothermic reactions are the reactions which take in heat, so they require heat. So if we increase the temperature, that will create very good impact on the reaction. So shifting the position of the equilibrium will be towards right, and reaction yield will be increased. But if you decrease the temperature of the environment, because the endothermic reaction is a reaction which require heat, and if you decrease the temperature of the environment, that will have bad impact on the reaction. So the shift in the position of the equilibrium will be towards left, and reaction yield will be decreased. Next thing that we are going to read is the changing pressure. So if the number of the moles of the gaseous reactants are greater than the number of the moles of the gaseous products, so simple words, number of the moles of the reactants are greater than the number of the moles of the products. So if you increase the pressure, so the number of the molecules of the gases will come closer. They will collide with each other more frequently. More effective collisions will be there. So the shift in the position of the equilibrium will be towards right, and reaction yield will be increased. And on the other hand, if you decrease the pressure, definitely the gas particles will move away from each other. Number of the effective collisions will be less, and shifting the position of the equilibrium will be towards left, and reaction yield will be decreased. Okay, if the number of the moles of the gaseous products are greater than the number of the moles of the reactants, so the moles of the reactants are already less. So if you increase the pressure, the shift in the position of the equilibrium will be towards left, and reaction yield will be decreased. And if decrease in the pressure is there, so the shift in the position of the equilibrium will be towards right, and reaction yield will be increased. Okay, the addition of the catalyst. This is very, very important point. The addition of a catalyst will increase both forward and reverse reaction rates. In the case of the catalyst, both reaction rates are increased by the same amount, and therefore there will be no equilibrium shift, because catalyst will have impact on both forward as well as backward reaction. So there will be no effect on the state of the equilibrium. Okay, now two particular examples are going to be discussed, and all three factors will be discussed: concentration, temperature, and pressure. So look now, the important step in the manufacture of the sulfuric acid is the reversible reaction. So the reaction is 2SO2 plus O2. Equilibrium reaction is there, 2SO3. Okay, and this minus sign shows that it is an exothermic reaction. So look now, the effect of the temperature is going to be discussed. So this is already a exothermic reaction. So exothermic reaction is a reaction in which heat is given out. So if we increase the temperature of the environment, that will have bad impact on the reaction. So the equilibrium direction will be towards left, and the product yield will be less. And vice versa will be there if we decrease the temperature of the environment. That will have good impact on the reaction, and the direction of the equilibrium will be changed towards right, and product yield will be increased. So look now, as the forward reaction is exothermic reaction, lowering the temperature should cause the equilibrium to move to right, producing more sulfur trioxide. Okay, next thing that we are going to read is the effect of the pressure. So here you can see the number of the moles of the reactants are greater than the number of the moles of the product. So if we increase the pressure, the molecules will come closer, they will collide more frequently, more effective collisions will be there. So the reaction yield, the product yield will be increased, and vice versa is there. So look now, 2 moles of the sulfur dioxide molecule react with 1 moles of the oxygen molecule to produce 2 moles of the sulfur trioxide molecule. An increase in pressure will cause the equilibrium to move to the right. The next thing that we are going to read is the effect of the concentration. So if we increase the concentration of the reactants, there will be more molecules of the reactants. They will collide more frequently, more effective collisions will be there. So product yield will be increased. So look now, removal of the sulfur trioxide. So if we remove sulfur trioxide, so in other words, concentration of the reactants will be increased. So that's why equilibrium to move to produce more sulfur trioxide. Okay, the same type of the example is going to be discussed in Haber process for manufacturing of ammonia. So the effect of the temperature, this sign, minus sign is showing that this is exothermic reaction. So the same effect that was in the previous example observed. So if we decrease the temperature, that will have good impact on the reaction. So equilibrium reaction will move towards right, product yield will be increased. So look now, the forward reaction is exothermic. If the system is cooled, it means temperature is going down. The equilibrium will move to opposite change, that is move to right, producing more ammonia. Next, effect of the pressure. Look now, the number of the moles of the reactants are greater than the number of the moles of the product. So increasing pressure will have good effect on the reaction. The reaction will move towards right, more product yield will be there. Okay, the final thing is effect of the concentration. So if we increase the concentration of the reactants, that will create more number of the particles of the reactants. They will collide more frequently, more effective collisions will be there. So the reaction will move towards right, and more product yield will be there. So this was the lecture, students. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.